Okay, so if you will go ahead and pull out your angles and their measures packets. Okay. We'll do a quick recap of what we did yesterday, and then I want to go ahead and do a few more problems where we're sketching radian measures. Okay, so yesterday for the first time I introduced radians. And we know that one full revolution is going to be 2 pi radians. But where does a radian come from? So we talked about this idea of taking the length of a radius in a circle. Whatever that length is, if I find that same length along an arc in the circle. If the radius and an arc length have the same length, the angle created between the two, that's 1 radian. Okay, so it's roughly 57.296 degrees. Okay, and then we started talking about a few other things. We know that 6.28 radians exist in 1 revolution. And we talked about why we have 2 pi, but this is what I want to go ahead and do. I just want to go ahead and continue sketching these angle measures. Okay, remember, if it's positive, then you're going to rotate counterclockwise. If it's negative, then you're going to rotate clockwise. Just like we did 360 earlier in the week, we broke 2 pi up. So 90 degrees is equivalent to pi over 2 radians. 180 degrees is pi radians. 270 degrees is 3 pi over 2 radians. And of course, if it's negative, you're just going in the opposite direction. Okay, so every class was different yesterday. How far did we get? So we did those 3 up there, right? We did pi, pi over 2, and negative pi over 4. Did we do any beyond that? We got to 7 pi over 12. Okay, so we only did 1. Okay, cool, cool, cool. So did we do 2 pi over 9?
We did 2 pi over 9 and then 7 pi over 4.
Okay, cool. So now we're on the third one. So here is our first one. So let me go ahead and erase this. La, la, la. Okay, so 7 pi over 6. Now, the previous 2 that we did yesterday, they were fractional values. So it's always a good idea to compare your value to the values you have in your coordinate plane as you're rotating. But this one's different. This is an improper fraction. So a really good strategy when you're trying to graph these radian measures is to rewrite it as a mixed number. Can anybody help me with 7/6? What is that? Okay, 1 and 1/6 pi. Now, this kind of breaks it down and makes it easier as you're rotating around your coordinate plane. So this is positive. So I know I'm going to be over here. I'm going to rotate counterclockwise. Remember, I'm going to start in standard position. You always want to begin with your whole number. Okay, so first thing I need is 1 pi. So I'm going to start here. I'm going to rotate around. There's my 1 pi. Okay, so I've got that taken care of. Now I only want to rotate an additional 1/6. And this is where I was talking about a few moments ago, comparing the values. Remember that 1 quadrant is pi over 2 radians, 1/2 pi. Okay, so we want 1/6 pi. Okay, how does 1/6 compare to 1/2? Is it smaller or is it larger? 1/6 is smaller than 1/2, right? So that means it's going to push it beyond pi, but only into quadrant 3. So this right here would be 7 pi over 6. Now, for argument's sake, if that fraction that we had in my mixed number, if that had been bigger than 1/2, well, that would have pushed me into quadrant 4. All right. So let's try another one of these. Cool, 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 cool. By the time you leave today, I'm sure you're going to think, man, these are pretty rad. Did I? You know what? I stand by it. Okay. 15 pi over 8. 15/8 pi. 15/8 pi. So it is another improper fraction. Okay. Mason, what's that mixed number? There we go. 1 and 7/8 pi. Exactly. Okay. So don't say it out loud. Take a few seconds. Think about what quadrant this is going to be in. Okay. And then we'll go ahead and check to see if we're correct. So just like before, I'm going to take care of the whole number. So I'm starting in standard position. There's 1 pi. Okay, so that's done. Now, I've got to rotate 7/8 pi more. Okay, what's bigger, 7/8 or 1/2? 7/8. So bigger than 1/2, this is going to go ahead and push me into the 4th quadrant. So that should be 15 pi over 8. Now, where it is exactly, you know, the more we do these, you'll get more accurate. Right now, I'm really just concerned with you getting it in the right quadrant. That's what I'm wanting. Okay. All right. So let's go ahead and try another one. So now to number 5, negative 5/3 pi. Negative 5 pi over 3. Okay, how's this one different? It's negative, so I'm not going to rotate counterclockwise. I've got to rotate clockwise. But it's still the same idea. A negative just tells you the direction that you're rotating. Okay. So I need a negative 5/3 as a mixed number. Mariana, can you help me out with that? Perfect. Negative 1 and 2/3 pi. Okay. So just like before, I'm going to start with that first value. Okay. So I got to go negative 1 pi. So I'm right here, standard position. There's negative 1 pi. Okay, so that's taken care of. Now, the whole value is negative, so it's not that we have to say negative 2/3, but you can still use the same idea. Remember, 1 quadrant is 1/2 pi. How does 2/3 compare to that? It's larger. So what quadrant would this be in? This would be in quadrant 1. Because see, right here, now we're at negative 1 pi. That's what we originally wanted. So now if I continue to rotate, there's 1/2 pi, so there's 2/3 pi. So this would be negative 5 pi over 3. Okay. How are we doing? Is this starting to make sense? Okay. Is anybody confused? Cool. All right. Well, let me go ahead, give you another one, because you're probably thinking at this point, Mr. With, this is so easy, I could even come up and show you how to do one. Okay. So my next one here, negative 17 pi over 6. So I'm going to give you a few seconds to go ahead and take care of that one, and then somebody's going to come on up and help me. And I'm going to introduce you to something we're going to be using a lot throughout the year. For students I've had before, you already know what's coming. Okay. So change that to a mixed number. Let's see what we get. Okay. Now, occasionally, it might happen. I know it seems kind of insane, but I might ask for a volunteer and nobody says anything. It's crazy. So, on the off chance that that happens, I've got what I call the Wheel of Destiny. Because I'm not choosing, Destiny is choosing. Now, in this class, we go to seat 32. So I'm going to have everybody's seat number in here. Let's give this a good shuffle. Okay. And then once I spin it, whoever number it lands on is the lucky winner. Now, I will tell you, especially in the beginning, if you are photosensitive of any kind, if like flashing lights or quick colors kind of bother you, don't look directly at the wheel when it's spinning. Okay. All right, here we go. Who is coming up first? Okay. But, yep, unfortunately, there is something we can't do that. That was just a test. Okay, so here we go. Who wants to end up on 1 again? Oh. 7. Okay. All right, now, Vanessa, you do have an injured leg. Would you still be okay to come up? She's a trooper. There we go. Come on up. Now remember, you're not by yourself. If you need help, we got a lot of great people here who are going to help you out. Okay. So first up, what's the mixed number for negative 17/6? Negative 2 and 5/6 pi. There we go. Okay, so we have to rotate a negative 2 pi first. There you go. She goes right to it. That's correct. That is absolutely right. Fantastic. Okay. Now, let me just elaborate on what Vanessa did. So, that negative 2, if we start here, there's negative 1, there's negative 2. You've taken care of that first value, but you're exactly where you started. Okay. Now, we want to go an additional 5/6. That is bigger than 1/2. So, there we go. Okay. Fantastic. Now, I'll go ahead and ask you folks, okay, I've got several more examples. If you feel you want the practice, we'll keep going. If you feel confident, we'll stop. Is there anybody who wants to do maybe one or two more? Don't let peer pressure affect you. Oh, I got a hand. Let's do it. Okay. So that was, what was that one? No. That was number 6. Let's go to number 7. 27 pi over 4 is our next one. Okay. Now this one's improper, but it is what? It is positive. Okay, so we're going to be rotating counterclockwise. Excuse me. It is definitely improper. Okay, so try it again. Let me give you a few seconds. Sketch this on your paper. Everybody think they've got a quadrant? Okay. Let's take a poll this time. Okay. How many people think quadrant 1? Show of hands. Okay. Oh, I had 1, but then somebody changed their mind. Okay. Quadrant 2. That's a lot of hands. Quadrant 3. Quadrant 4. Okay. How many people are not going to vote? There you go. That's okay. You know, it happens. Okay. So quadrant 2 is absolutely right. 27/4 is 6 and 3/4 pi. So I'm going to start here in standard position. Here's 1, 2 pi, 3, 4, 5, 6. Okay. So I rotated 6 pi, and I'm exactly where I started. But now I have to go an additional 3/4. 3/4 being bigger than 1/2. So you're absolutely right. It should have ended up in the second quadrant. Okay. Yes, sir. Okay, so what's confusing to you? Well, the line is 1/2. So see, as we rotate, okay, so this right here, this is the division that ends the boundary on that first quadrant. So right there, that's 1/2. Okay. So then as soon as you get to the next axis, that ends the next quadrant. That's exactly 1 pi. So that's where they end. Okay. So when I'm looking at these fractional values, that's why we're comparing them to what's coming up. Oh, yeah. Absolutely. Absolutely. Because see, here's the thing. I'm glad you brought that up. One thing I'm going to show you how to do on Monday is how to convert between degrees to radians and back again. So like, for example, you said 120 degrees. Okay. Well, 120 is bigger than 90, less than 180. So let's say we're looking maybe something like that. I think I went a little further than I needed to. Okay. But here's what you're going to come to find out. If I go ahead and convert that to a radian measure, 120 degrees is also 2/3 pi. Just like these that we already see here on my coordinate plane. Like pi over 2 radians, that is 90 degrees. They're equivalent, they're measured differently, but they're still the same location. So that's all there is. Does that kind of help?
I meant like, how do you know where the 2 pi are? Like, how would pi over 2?
Oh, like how would we know? Oh, that's what we're doing. We're comparing it to what we got. Okay, like let's say 2/3 pi. Okay, so you remember these boundaries that I was talking about? This one right here is what? That's 1/2 pi. This boundary right here was exactly 1 pi, right? So let's say we're looking at 2/3 pi. Okay, so I'm going to go ahead and start here in standard position. Well, how does 1/2 compare to 2/3? It's smaller, right? So I know that when I go ahead and start to rotate, because my value is larger than that, I know it's going to push me into the second quadrant. So now compare it to the next one. How does 2/3 compare to 1? So see, that tells me that I can't possibly cross it because it's not larger, so it has to stop somewhere in that quadrant. That's what we're doing. We're just comparing our values. Does that kind of help out a little bit? Cool. Very cool. Very cool. Okay. What do we think? Do we want to do another one? Is that Kagan? You want to help me? Sure. Okay. Let's see here. We just did that. How about a 5/18 pi? Okay. So this is exactly what we were just talking about. Okay. So I'm going to start here. It's positive. So I'm going to rotate counterclockwise. So how does 5/18 compare to 1/2? If you're going to tell me that 5/18 is smaller, it has to be in quadrant 1. If you're going to tell me that 5/18 is larger, it has to be in quadrant 2. What do you think? It's quadrant 1. That's exactly right. Okay, so 5/18, you're probably looking at something like that. Let's think about it. What's half of 18? So 9 pi over 18, that's exactly pi over 2. Okay, so I knew that it had to be less with only having 5/18. Okay, is that starting to make a little more sense? Great, fantastic. Okay, well, nice. Okay, how are we feeling? Yes, sure. Okay, everybody else, how are we feeling? Feeling pretty good? Okay, fantastic. Okay, so we're going to go ahead and stop there for today. What time are we out of here? 55. Okay, so we've only got 10 minutes left, but that's